Right now, as you're listening to these words, there are human beings living 250 miles above your head, floating in a metal capsule, separated from the infinite void by just a few inches of aluminum and glass. We've all imagined at some point what it would feel like to float among the stars. The freedom, the beauty, the perspective of seeing our world as it truly is, a small blue sphere suspended in immensity. But there's something we rarely consider when we look at those romantic images of space. Something the space agencies don't emphasize in their promotional videos. Something that connects us in a profound and unsettling way to the cosmos itself. What happens when a human being dies in space? The question sounds morbid, dark, uncomfortable, but the answer is surprisingly poetic. But before we answer that, we need to understand something fundamental, something Carl Sagan spent his life explaining to us. You see, when Carl Sagan said we are made of star stuff, he wasn't being metaphorical. It wasn't a pretty phrase for a motivational poster. It was literal, completely literal. Every atom of calcium in our bones, every molecule of iron in our blood, every particle of carbon that forms our cells, that structures our DNA, that literally makes us who we are, was forged in the burning heart of stars that died billions of years ago. Let me explain how this works. In the core of a star, the pressure is so immense, the temperature so extreme, millions of degrees, that hydrogen atoms fuse together. They transform into helium. And when that happens, they release energy. An amount of energy so colossal it's hard to comprehend. That's the light you see when you look at the sun. That's the light that has allowed life to exist on Earth for billions of years. Nuclear fusion, hydrogen becoming helium. But here's the fascinating part. When a star ages, when it starts running out of hydrogen, it doesn't just turn off. No, it begins to fuse helium into carbon, carbon into oxygen, oxygen into neon, into magnesium, into silicon. Every element we know, every single one of the 118 elements in the periodic table, with only 3 exceptions, hydrogen, helium, and lithium, which were formed in the Big Bang, were created inside stars. And when those massive stars finally die, when they collapse in on themselves and explode as supernovas, they scatter those elements throughout the universe, like cosmic seeds, like a gift from the cosmos to itself. Those clouds of stellar dust drift through space for millions of years until gravity brings them together again, and they form new stars, new planets, our sun, our planet, and eventually, us. You and I are not outside observers of the universe. We're not visitors in this cosmos. We are the cosmos itself, arranged in a way that allows it to know itself, to feel, to think, to wonder where it came from. Now, with that in mind, let's return to the original question. So far, no human being has died in the vacuum of space. 3 Soviet cosmonauts died during descent in Soyuz 11 in 1971 when their capsule depressurized. The 7 crew members of Challenger died during launch. The 7 on Columbia died during re-entry, but no one has died in deep space, in the actual vacuum. However, scientists have studied what would happen, and the answer is strange, counterintuitive. First, forget everything you've seen in the movies. Your body wouldn't explode. Humans aren't balloons filled with air. Our skin is strong enough to contain the internal pressure. What would happen is this. In absolute vacuum without atmospheric pressure, the water in your body would start to boil, not from heat, but from the absence of pressure. The water on your tongue, in your eyes, in your tissues, would begin to evaporate. You'd have about 15 seconds of consciousness, maybe less. Your last breath would be expelled from your lungs. Holding it in could do more damage. You'd feel the water evaporating from your mouth. Your vision would blur, and then nothing, unconsciousness in seconds, death in minutes. But after that death, and this is where the story becomes fascinating, your body wouldn't decompose like it would on Earth. On Earth, the bacteria in your gut, on your skin, would immediately begin to break down your body. Other organisms would join in. In weeks, in months, you'd return to the Earth. Dust you are, and to dust you shall return. But in space, there are no bacteria, no oxygen for oxidation, no insects, nothing that could decompose you in the biological sense. Imagine this, a human body lost in the void. If you're in the shadow of a planet in the total darkness of space, the temperature could reach minus 450 degrees Fahrenheit, nearly absolute zero. You'd freeze solid like ice. If you're exposed to direct sunlight without an atmosphere to filter the radiation, the side facing the sun could heat up to 250 degrees. The other side would stay frozen. A corpse half-baked, half-frozen, slowly rotating through eternity. You'd mummify. You'd be preserved, like those ancient mummies found in glaciers, almost perfectly preserved after thousands of years. But here's where the story becomes truly cosmic. Because even in space, even mummified and frozen, you wouldn't last forever. Cosmic radiation, high-energy particles that cross the universe at near-light speeds, would start bombarding you, slowly, atom by atom, molecule by molecule, not in years, not in centuries. This would take millions of years, tens of millions, hundreds of millions, but eventually, inexorably, you'd begin to disintegrate. That body that once had a name, a story, dreams and fears, friends and family, hopes for the future, would slowly become dust, dust that would drift through the cosmos. And now think about what that means. Those atoms that were once part of you, the calcium that formed your bones, the iron that carried oxygen in your blood, the carbon that structured every cell in your brain, would begin a journey. They could drift for millions of years, cross light years of distance. Some might be captured by a star's gravity and fall into it, to be recycled once more in the nuclear forge of its core. Others might join a cloud of interstellar dust, one of those magnificent nebulae we see in Hubble photographs, the Eagle Nebula, the Orion Nebula, clouds of creation where new stars are born. And maybe, just maybe, a billion years in the future, those atoms that were you would become part of a new planet, a world we can't imagine, orbiting a sun that doesn't yet exist. In an epoch where our civilization will be barely a whisper in Earth's geological record. And if that planet had the right conditions, liquid water, an atmosphere, a stable star, maybe, eventually, life would emerge. Maybe beings completely different from us, maybe similar, who knows? But in their bodies, in the structure of their cells, in the DNA of a creature looking up at its own night sky, would be the atoms that were once you. Do you see now why death in space isn't the end? Carl Sagan understood something most of us can barely grasp, something that requires us to expand our perspective beyond a human lifetime, beyond our species, beyond our planet. The universe isn't a collection of separate objects. It's a system, a cycle. Matter and energy constantly transforming, recycling, being reborn. Stars are born from clouds of dust. They live for millions or billions of years. They die in spectacular explosions. That dust forms new stars, new planets, new living beings. Those beings live, die, and their atoms return to the cosmos, again and again, for all eternity. A cosmic waltz that's been dancing since the Big Bang and will continue dancing long after the last human thought has faded. And he was right, you know. Sagan was right. Dying in space isn't the end. It's perhaps the most honest way to complete the cycle, to close the circle that began 8 billion years ago with the Big Bang. The atoms that were once you will travel through the galaxy. Maybe they'll collide with a comet drifting through space for millions of years. Maybe they'll be captured by the magnetic field of a young star. Maybe they'll be swept up by the solar wind, those invisible currents of particles flowing from stars. Maybe, just maybe, they'll help create a new world, where new forms of life will wonder like us where they came from, why they exist, what it all means. And if you could, from some plane of existence we can't imagine, observe that new living being, separated from you by 1 billion years and 1,000 light years, would you feel any connection? You should, because literally you'd be looking at yourself, transformed, recycled, reborn. That's why when Sagan looked at the stars, he didn't see distance. He saw connection. He didn't see emptiness. He saw home. He didn't see cold, indifferent objects. He saw family. You know, there's something deeply ironic about the human condition. We spend most of our lives worrying about small things, our ego, our status, the superficial differences that separate us from each other. We divide ourselves by imaginary lines on a map, by the color of our skin, by the books we read or the gods we worship, by how much money we have in our bank accounts. But when you see the Earth from space, really see it like the Apollo astronauts saw it, like Voyager 1 saw it from 4 billion miles away, all those differences reveal themselves for what they truly are. Illusions, distractions, cosmic trivialities. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was lived out their lives. On a mote of dust suspended in a sunbeam. Sagan understood something most of us spend a lifetime never grasping. We're not important in the cosmic sense. The universe wasn't made for us. We're not the center of anything. We're incredibly small, incredibly fragile. Our entire existence as a species, from the first hominids until now, is less than a blink in the timescale of the cosmos. And this is a huge but, we are matter that has become conscious. We are the universe waking up and contemplating itself. We are stardust that has learned to think, to feel, to love, to ask questions about its own nature. And that's extraordinary. We've looked back in time to the first moments after the Big Bang. We've found thousands of planets orbiting other stars. We've discovered the fundamental laws that govern reality. We've split the atom and mapped the human genome. We're a young species. We're just beginning. And yet, in just a few thousand years of civilization, we've managed to understand our place in the cosmos. So what does it mean to die in space? It means returning home in the most literal way possible. It means that your atoms, which were forged in stars, which formed rocks floating in space, which eventually organized themselves into cells, into a body, into a mind capable of contemplating its own origin, will return to the cycle. You were born from stars, and to the stars you will return, not metaphorically, literally. And maybe somewhere in some future time we can't imagine, those same atoms will be part of another being looking up at its own sky and wondering, where did I come from? What am I? Because space isn't a strange and hostile place. It's literally where we come from, and where we all eventually will return. Carl Sagan taught us to look at the universe not with fear but with wonder, not as strangers but as integral parts of its grandeur. He taught us that death isn't the enemy. Separation isn't real. Isolation is an illusion. We're all connected, not just with each other as humans, but with every atom in the universe, with the stars that created us, with the planets that will someday form, with life forms that don't yet exist. We are the universe, experiencing itself, knowing itself, loving itself. So the next time you look up at the night sky, remember, you're not looking outward, you're looking home. And when your moment comes, whether here on Earth or floating among the stars, it's not goodbye. It's just a return.